So, hello everyone, a very good evening to each and everyone out there, and I welcome you all to this amazing platform of PW Gulf. So, this is your math educator Shivangi Rajput, and in this particular video, students, we are going to study about the chapter surface area and volumes in one single shot. So, we are going to understand about what is actually surface area, what is its volume, and when we talk about the three-dimensional objects like your cube, cuboid, cone, cylinder, and everything. So we will be dealing with what is lateral surface area, curved surface area, total surface area, and along with this, the volume of a particular three-dimensional object. You have learned about each and every of this thing in your previous classes, right? And in this particular video, we are going to discuss about the combinations of object as well. Apart from different things like a cube, like a cuboid, and everything, we are going to deal with what? One single shot of the chapter, and we are going to study about the combinations of figures along with the different type of things that we study in this particular chapter. So let's begin with it. So the very first thing that we have is our table of content today. So we are going to learn about, students, the introduction to the chapter, about surface area. Then we are going to learn about what is volume. After that, we are going to learn about that what have we read so far in this particular chapter, along with the question related to the combination of figures and question based on melting and recasting. So all these are the concepts that are different from your book, but of course are very important as well. So we are going to do all these concepts in this ultimate recap. So let's begin with the very first thing, students, to the introduction to the chapter, right? So let us say that we have a bottle over here, right? So when we talk about the surface area of this bottle, what does that mean? That basically the plastic with which this bottle is made up of, this is what is known as the surface area. The second thing that we talk about is the volume. That means how much water this bottle can hold. Or if I talk about this room, students, then how much air this room can hold up to, that becomes its volume. So volume is basically what? A particular capacity of any of the object that is in front of us. For example, you have a tank, right? So in that tank, how much liter of water can come? That is its capacity, right? When we talk about a particular bottle, or we say room, or we say that how much sugar syrup can be there in a gulab jamun, that is also its capacity. So let's start by reading some of the particular things that we have already learned in this chapter. So let's start with the CSA, TSA, and your volume, right? These are the three different things, students, that we are going to learn in this particular chapter. So when we talk about the CSA, or let me say LSA, what is the full form, right? CSA means curved surface area. So whenever we are learning about the figures such as your cube, cuboid, right? When we have a figure such as your say that has, faces, plain figures, right? So that is where LSA comes, that is lateral surface area. But whenever we are talking about faces such as a cylindrical, right, objects such as a cylinder, objects such as a cone, objects such as sphere and hemisphere, so all these things end up in what? All these things end up as your curved surface, which in turns add up to your CSA. So these are all the things that we are going to discuss in this particular chapter. So this is basically surface area, the space occupied by a two-dimensional flat surface is called its area. Very true. If I have to calculate the area of this board, that will be simple, length into breadth. The next thing that we have is, it is measured in square units. We always know that area is always in centimeter square or meter square. So that square means what? Area. We know that if we have to measure a line is always measured in centimeters, meters. That is a line. When we talk about area, that will be centimeter square, meter square. That is square area. Whenever we talk about volume, we will be learning about what it will be. The area occupied by a three-dimensional object by its outer surface is called the surface area. It is also measured in square units because it is area, so it will always be measured in your square units. Generally, area can be of two types: total surface area, curved surface, and lateral surface area. So total surface area is one thing that if you talk about the room you are sitting in, just imagine, just look at this room where you are sitting in. So basically this ceiling, this floor, and all the four walls around you forms what? The total surface area of this room. But if you were to paint this room again, so you know that painting is never done on the floor and the paint is hardly done on the ceilings. The paint is done on the four walls. So if you will just see in your room the four walls, that is the front one, the back one, the sides and the sides. So these four walls, students, make up what? Make up your lateral surface area. Now when we talk about figures such as cylinder and sphere, so we have, for example, this is a cylinder, right? So when we talk about the total surface area, means this curved part, this top and this bottom of the cylinder too. But when we talk about the curved surface area, because whenever the figure has a curved surface, we take the curved surface area. You should know the difference between curved surface area and lateral surface area. So whenever we just talk about the curved surface area, student, that means only this curved part, the top of the cylinder and the bottom of the cylinder is not taken. So this is how we deal with it. This is how we do it. That what? The curved surface area and the lateral surface area. The next thing that we have is volume. Now what is a volume, students? The amount of space measured in cubic units. Cubic units means either centimeter cube or meter cube, that an object or a substance occupied is called its volume. It is so because a sphere is a three-dimensional shape. So whatever occupies a three-dimensional shape, so the capacity it has, the space inside it which can be filled, is known as what? Is known as the volume of that particular thing. I hope this thing is clear with everyone. All right, let's move forward. Now these are particularly the formulas that we have done for cuboid, cube, cylinder, cone, sphere, hemisphere and hollow hemisphere. So let's just quickly recap it. So the curved surface area, we can say what? The lateral surface area too, right? We can say the curved surface area and we can say the lateral surface area too. So the cuboid has a lateral surface area of 2 into L plus B into H. That means twice of length plus breadth. Let me just write this thing for you. All right. So when we have a cuboid, student, first of all, we are talking about cuboid, right? So when we have a cuboid, students, what do we do? So for cuboid, your lateral surface area will be equivalent to 2 into H L plus B. When we talk about the total surface area of a cuboid, this will be equals to 2 bracket length into breadth plus breadth into height plus height into length. And whenever we talk about volume of the cuboid, student, so the volume is equals to length into breadth into height. Now adding to this, there is one more thing that you need to know and you should know: diagonal of a cuboid. Right? So the diagonal of the cuboid is calculated as under root of L square plus B square plus H square. So these are the four formulas that you will be basically having in your particular questions or something. So these four formulas might be used in calculating things. The next thing that we have, students, is cube. Right? Let's talk about cube. So it's simple. The lateral surface area of cube, the lateral surface area is equivalent to 4a square. As simple as that. The total surface area of the cube is equals to 6a square, and the volume of cube is equivalent to a cube, and the diagonal of the cube is calculated as under root 3 into a. So these are particularly the 4 different formulas that you will be using for a cube figure. The next thing that we are having, students, is particularly, let's see the figure. Right, for this, let's go to the figure. What we have is cylinder. So for cylinder, the curved surface area is 2 pi RH. Right, what is the curved surface area, students? For a cylinder, the curved surface area is simply 2 pi RH. Right, after that, for your total surface area, it is 2 pi r bracket r plus h, and the volume is pi r square h. Let me just write down in this so that you will have it as a whole. So this is 2h L plus b. This is 2 LB plus BH plus HL, and volume is length into breadth into height. The curved surface area is 4a square. Total surface area is 6a square, and the volume is a cube. Now for a cone, when we talk about, students, the curved surface area of cone is pi RL. The total surface area is pi R L plus R, and the volume is 1 by 3 pi r square h. I hope that now it is visible to each and everyone out there. Now for sphere, when we talk about, see, the total surface area and the curved surface area of the sphere remains the same. How it remains the same, students? It remains the same because overall, just imagine a ball, right? So all the surface is the total surface area. There is no lateral along with, because whole of that thing is particularly curved, and the volume is equivalent to 4 by 3 pi r cube. The next thing that we have is, this is 2 pi r square. For hemisphere, this is 3 pi r square, and this is 2 by 3 pi r cube. So these are the things, students, that you generally need to do. It's not like you have to, memorize this particular chart all at once. Once you start solving the question, students, so what will come across when you start solving the question and start writing the formulas along with, so eventually by your own thing and automatically you will be learning the formulas. You just don't have to sit and just rant up all, right? You can simply just put them in the questions and you can understand them. Let's see the type of questions. Right, so basically surface area of a combination of particular solids. So basically what over here needs is, you might see certain figures that is combination of things. For example, in the very first thing, this ice cream cone, if I talk about, so it's a combination of a hemisphere and the cone that is attached, right? The second thing that we have is, for example, if you see this figure, so this figure is a combination of a cone and a cylinder. So there are multiple images or multiple questions that you might see, for example, like this, where particular object is a combination of 2 different figures. So what we will be doing, we will be just applying the formulas individually, and with this we can come how to apply the formulas individually once, and secondly what we can do actually to do it when it comes as a whole. So the question certain time might come direct, like for example they may ask one direct question, and the question be that volume of a cube is 216 centimeter cube, find its diagonal. Right, this can be one of the question that you might see in your exam. Now first of all, Just look at the question. They have asked you for the diagonal given that the volume of that thing is given to you. Now, the very first thing that you have to see is what? From this volume, can you calculate the side? Right? So you have to think of that from this volume that is given to you, can you calculate the side of the object? Of course you can. So the very first thing is, we know that the volume of cube is a cube, which is equals to 216 centimeter cube. The next thing that is given to us is a can be equals to cube root of 216. And from here we can calculate the side of the cube, that is 6 centimeter, as you should be aware of that 216 is the cube of 6. 6 into 6 into 6. So by this we can simply calculate the side of the cube. The next thing that we have over here in this question is to calculate the diagonal. We know that the diagonal of a cube, students, is calculated by under root 3a, which is equals to under root 3 into 6, which is equals to 6 root 3. If you want to, you can leave the answer over here, students. If you don't want to, what you can do, you can put the value of root 3 as 1.732 and calculate the final answer in your particular decimal. So this is what one thing again that you can be doing. The next type of simple question that might come is, for example, it's say a cuboidal room, right? Basically it's a cuboidal room of dimension 4 into 5 into 6 centimeter, right? Calculate the cost of whitewashing, for example, at rupees 5 per meter square. Now this is the second direct type of question that you can see in your exam, students. And what does this question means? It says over here the cuboidal room of dimension 4 into 5 into 6 centimeter. So there is a cuboidal room with such dimension and we have to calculate the cost of whitewashing at rupees 5 per meter square. See, what we can do is, first of all, I have already told you that the whitewashing means for the 4 walls. So the very first thing that we have to calculate is the lateral surface area, which is equals to 2HL plus B. The next thing that we have to do is put the values. Whenever the values are given in straight multiplication, that means the first one is the length, the second one is the breadth, and the third one is the height. So this simply means 2 into H, length that is 4 plus breadth that is 9. So we have what? 12 into 9. What we got? 12 into 9, which is equivalent to 108 centimeter square. Now this is simply what the area that needs to be whitewashed. The next thing that we have in front of us is what will be the cost, students. So cost, if for 1 meter square, if the cost is rupees 5, so what do you expect will be the cost for 108 centimeter square? So basically for 108 meter square, it will be 108 into 5. So we have 5 8s are 40, 0, 4, 4 here, 5 1s are 5. So we will be giving 540 rupees for whitewashing. I hope this thing is clear with everyone, right? Now let's move forward to certain questions which are, let's say, a combination of figure. So over here it is saying that we have, okay, this will be 22 by 7. So Rashid got a playing top lattu as his birthday present, which surprisingly had no color on it. So basically you got a gift with no color on it. So the gift was like this, which is a lattu, a top. He wanted to color it with crayons. The top is shaped like a cone, surmounted. Surmounted means that the hemisphere is above, on it, surmounted by it. The entire top is 5 centimeter in height and the diameter of the top is 3.5 centimeter. Find the color he has, find the area he has to color. See, if this is the top and the lattu, so as you can see, he has to clear this curved surface area of hemisphere, the very first thing. The second thing, he has to cover this curved surface area of the cone. So we will be understanding how to find two different things: curved surface area of hemisphere, curved surface area for the cone. So let's calculate it, students. Let's calculate it. So basically over here what we have is, first of all, we got that what we have to choose, right? So basically the area to be colored, students, is nothing but the curved surface area of hemisphere, which we have to calculate individually, adding upon the curved surface area of cone. So these are the two things that we have to calculate. The other thing that we have to find out first is, we do not know the height of the cone. Just see this diagram very carefully. If this diameter is 3.5, so the radius will be 3.5 by 2, yes or no? What I'm talking about it, if diameter is this, so the radius will be 3.5 divided by 2. Not only this radius, students, this will also be the radius of the hemisphere. So from here to here, this will also be 3.5 by 2. So for the height of the cone, if we talk about, if I just subtract 3.5 from this 3.5 by 2, we will be getting the height of the cone, right? So let us calculate the different things that we need to find out. Just give me a second. Alright, let us just quickly find out the different things that we have to find out. So the very first thing that we have to do is, over here, that area to be colored is equals to CSA of hemisphere plus CSA of cone, right? The next thing that we have is, let's calculate the curved surface area of hemisphere first, right? For the hemisphere. So the curved surface area of hemisphere is equivalent to what? Remember, 2 pi r square, 3 pi r square, and then we have 2 by 3 pi r square h. So if you don't remember the formula, students, you can quickly jump to the slide. And over here we have what? 2 pi r square as the curved surface area of hemisphere. So let's quickly solve it up. Let's see how we can do it. So curved surface area is equivalent to 2 pi r square, which is equals to 2 into 22 by 7, and the diameter is 3.5 centimeters. So the radius will be equivalent to 3.5 by 2 into 3.5 by 2. So from 2 over here, 2 cancel, 7, this is 0.5, right? So basically this is 11. 0.5 is equals to 1 by 2 into 3.5. So let us multiply this figure, right? That is 35 by 11. So you get 35 and 35, 5, 3, 8, 3, 8, basically 11 into 3.5 is 38.5 divided by 2, and you will get 1, then you have 9.25. So basically the curved surface area of the hemisphere comes out to be 19.25 centimeter square. The next thing we have to calculate is what, students? The curved surface area of the cone, right? First of all, the height of the cone, right? Over here the height of the cone will be equals to 5 minus 3.5 by 2 will give you what? 1 point, when you will have 15.75, right? So you have 1.75. So 5 into 1, 5 minus 1.75. So this will be equivalent to 3.25 centimeters. So this will be what, students? This will be the height of the particular cone that is given to you. All right. The next thing that we have is, over here the curved surface area of cone is equivalent to pi RL. So we need to find the L, and L is what? The slant height. Now let us understand this concept. See, if you have a cone, right? Let's make a cone. So if you have a cone, students, you have three things in this cone. And what are those three things? Firstly, the radius. Secondly, the height, and third is this slant height, which is referred to as L. Now when you will see this H, R and L, you will see that they are making a right angled triangle to their own self. So this is what? Simply a right angled triangle in front of you. Now this right angled triangle, students, from this we can calculate L, which will act as the hypotenuse of the particular figure. So L will be equivalent to under root of h square plus r square. What does this mean? That hypotenuse is equals to perpendicular square plus base square. So this is what is given, this is what is given in the question, and we can find it out. So now the height is given to us as 3.25. The radius is given as 3.5 by 2. So what we have to calculate? We have to calculate this slant height, students. Why? Because in the formula it is pi RL. And if L is something that we have to put in the equation, so we have to stick with that particular thing, right? So let's see. P square plus B square, and L is equals to h square plus r square. So L will be equals to under root of h square, that is 3.25, plus r square, that is 3.5 by 2 square, right? So basically over here it's also a square. So we will be calculating 3.25 square. That means, students, 325 into 325. So this will give us 5 into 5, 25, 2, 5 into 2, 10, and then we have 12. 5 3s are 15 and 16. Then we have basically 325 double. That is 650. So 650 will come over here. Then we have simply 3 into 5, 15. 1, 3 2s are 6, 7, and 3 3s are 9. So we have 5, 2, 6, 1, 14, 15, 5 here, sorry, right? And then we have 10. Decimal over 4 places, so we have 10.5625. So over here we have 10.5625. Right? Then we just do 3.5 square, or we can say 35 into 35, students. 5 5s are 25, 2, 5 3s are 15, 16, 17. Then we have 5 3s are 15 again, and 3 3s are 9, 10. So what we have? 5, 12, 1, 2, and 1, 2, 2.5. Plus 1, 2.25 upon 2 square is 4. Right? So what we can do is, now over here there is nothing but 1. We can take the LCM, or if you wanted to, you can directly solve this. Like, you can completely divide 12.25 by 4. Like 12.25 divided by 4. So what we will be having? 4 3s are 12 minus 0, 0.2, 0.0. Then we have 5. Then we will have 6. 24 minus 0, 1, then we have 2s are 8, and then we have 5. So 3.0625. So what we have? Under root of 10.5625 5, I guess, not 7, right? Plus we have 3.0625, right? From here, adding upon and finding the square root, we can simply find the length, that is slant height of this particular cone, and after that we will be just putting in the formula pi RL, where pi will be 22/7, radius will be 3.5/2, and slant height will be calculated, and then we will be getting a particular area for the cone. Now we will be adding the area of this hemisphere and the cone, and simply we can find out the final answer. So this is how combination of figures are deal with. Now let's learn about the question related to the combination of figures where two things are joined and then they form a very different figure. Now what are such type of questions? Let's learn about them. For example, this question. It says that initially two cubes, each of 10 centimeter edge, are joined end to end. What is it saying? That there are two cubes of 10 centimeter each, and both of them are joined end to end. After the joining of end to end, as we can see in the figure, the resultant figure that we have is a cuboid. See, this was the one cube. This was the second cube. Both of them joined together results in one single figure that appears to be like a cuboid. So when we have this figure, they are asking the surface area of the resultant figure. Especially students, when there is only and only surface area that is written in the question. So you might get confused that whether you have to take out the lateral surface area or the total surface area. So whenever only the surface area word is given to you, you only and only have to find out the total surface area always. So first of all, what we have, see. Now let's quickly jump to the figure, right? So basically, if I just look at this one cube whose every edge was 10 centimeter, so its height will be 10 centimeter, students, its breadth will be 10 centimeter, and the length will also be 10 centimeter. Same goes for the second cube, right? This will be 10 centimeter, this will also be 10 centimeter, and this will also be 10 centimeter. So these are the three things. But now when we have both the cubes joined together, which results in a cuboid, and if we can see that this cuboid that we have now has a height again of 10, has a breadth again of 10, but what changes is the length of the cuboid, which becomes 10 plus 10. So for the resultant figure, students, the length will be equivalent to 10 centimeter addition to the 10 centimeter, which will give you 20 centimeter. Right? The breadth that we have is still 10 centimeter, and the height that we have is still 10 centimeter. So these are particularly the values that we are having for the resultant cuboid that is in front of us. Now the second part is to find out the surface area. Surface area over here means the total surface area. So for the total surface area for the cuboid, the formula is 2 bracket length into breadth plus breadth into height plus height into length again. So let's substitute the value. Length is 20, breadth is 10. Breadth is 10, height is 10, plus height is 10 and length is 20. So this is what we are going to find out, the total surface area. Whenever only surface area is given, that means total surface area. So let's see over here, we have 200 plus 100 plus 200 again. That will give us 2 into 500, simply giving us 1000 centimeters square as the surface area, which is the total surface area for the resulting cuboid. I hope this thing is clear with everyone. Never ever please forget to mention the units of whatever answer you are getting, because if you are not writing down the units, that will actually get half of the marks deducted for the same. Now let's move to the next question, that is questions based on melting and recasting. Let's understand the concept first, right? For example, I have this bottle full of water. I have to pour this water into small glasses, right? So basically what will change? The volume in this water, in this bottle, right, will be equivalent to the volume of the glasses that I have poured it into. As simple as that. So even if from this bottle, if I have to pour the water in any of the container, the shape will get changed. From over here it was maybe in the shape of cylinder, and maybe that particular bowl is in a hemispherical shape. So the shape of the water of course will change, but what will remain the same, student, is the volume of a particular thing. In your childhood you might have done a lot of clay modeling, for sure. So a particular amount of clay is given to you, for which you can just make any shape out of it. So you can make, for example, an apple, a ball, or whatsoever. So the shapes might differ, but what remains the same is the volume of the clay that was initially given to you. So this is what the concept of melting and recasting means, where a particular big something is melted, recasted into, or remade into, reshaped into another small objects, and then we have to find a relationship between them. That means what? To find out simply the volume and equate it to both of them. So let's move to the first question. Alright, so it says the dimension of a metallic cuboid are 100 centimeter, 80 and 64. That means length, breadth and height respectively. It is melted to form a cube. Find the surface area of the cube. Now in this particular question, student, what is given to you? The volume of a cuboid is something that you can find out, and that only metal, see, metallic cuboid was there, then that metallic cuboid was melted and form a metallic cube. Now you have to find the surface area of that cube, but what remains the same is the volume. That remains the same. So can we say that volume of cuboid, the volume of cuboid is equivalent to length into breadth into height, which is equals to 100 into 80 into 64. Now 64 into 8, students, 8 4s are 32, 3, then we have 8 6 are 48, and then we are having 51. So 512. So what we have, 5120, and these 2000 centimeter cube will give you what? The volume of the cuboid, the very first thing. Now this volume of cuboid, students, will be equivalent to what? The volume of simply your cube. That means this 512000, this 512000 will be equivalent to the A cube. Alright, so this A cube, or we can say A, will be equivalent to the cube root of 512000. Right, so this is something from where we can calculate the side of your cube. See, the very first thing, the cuboid dimensions are given to you. The second thing that you have is, even though you have the dimension, but nothing else is related to the cuboid. But one thing is related, that this so-called cube, which is formed from the cuboid, has its volume same, because the same metal is reshaped, melted and recasted into a cube. Now what do you know? That the volume of the previous cuboid is equivalent to the volume of the cube which is just made. So what we did, that whatever volume of the cube that we have over here is, that is something what we done is to form a cuboid over here. I hope the things are clear till here. Alright, so basically now we have to find the cube root of 512000. Now this big number might be a bit scary for you people, but what you can always do is divide these numbers. Like you can divide, you can write this as 512 into 1000. So at least the cube root of 1000 is assured, that is your 10. You know that 7 cube is 343, right? After 7, see, 8 square is 64. 64 into 4, 8 fours are 32, 3, 48 and 51. So from here what we can get is, from here we can directly get that 512 is the cube of 8 and this is the cube of 10. So 8 and 10 both will come out and the side of the resulting cube will be equivalent to 80 centimeter. Now what is asked to find the surface area of cube? Again, only surface area is given to you in the question, which means what? The total surface area has to be calculated. So the total surface area of your cube, that means all the 4 walls of the room along with the ceiling, along with the floor. That means 6 surfaces into a square. That means 6 into 80 square. That means 6 into 6400 will give you the answer as centimeter square. So this is how the concept of your melting and recasting works, students, that once you are given a particular object, the volume remains the same and then you can carry forward with it. Let's see the next question for this. All right, so the question over here says is, how many shots, each having a diameter of 3 centimeter, can be made from a cubical lead solid of dimension 9, 11 and 12 centimeter? Now there are two different things. What is given in the question, students, that what you particularly have a cuboid, right? What you are having, you are particularly having a cuboid. Now in this cuboid, what is there for you? This cuboid is getting melted and recasting, right? This cube is getting what? Melted and recasted, and it is forming small lead shots that will be spherical in shape, right? So this cube is melted down and whatever you have, they are just shaped into small cubical spherical shots. Now it is given that these spherical shots that are made have a diameter of certain number, that is 3 centimeter. They are asking us how many shots. So what we know over here is the volume remains the same. Basically, the volume of this one cuboid, students, is equivalent to the volume of all these spherical shots that we have. Right, so what we can say is, we can say over here that the volume of your cuboid is equivalent to the volume of shots, but we don't know the number, so let us take that number be n. So let's assume that n spherical shots, n can be any number, we don't know how many shots we can make from that cubical box, right? So volume of cuboid will be equivalent to length into breadth into height, which is equals to n. The volume of shots that is in the shape of a sphere with the diameter of 3 centimeter will be equivalent to what? 4 by 3 pi r cube. Let's just substitute the value over here. That will give us 4 by 3 into 22 by 7. R cube means 3 by 2. Why 3 by 2? Because over here 3 centimeter is the diameter of your particular spherical shot. Into 3 by 2 into 3 by 2. So this will be simply equivalent to it. Now what we are having is, whatever is getting cancelled, we can cancel it out. 2 and 2 will get cancelled from 4 and this will get cancelled at 11. So what we are left with, students, 9 into 11 into 12 is equals to n into 11 by 7 into 3, that is 9. So see, 9 and 9 will get cancelled out. 11 and 11 will get cancelled out. So what we are left with, 12 into 7 is equals to n, and the number of spherical balls comes out to be 84. So basically what is the catch over here is that the volume of cuboid is equivalent to n into the volume of the spherical shots that are present in front of you. I hope this thing is clear with everyone. Alright, let's see the question, that is question based on if one object is inside another object. Now what does that mean? Let's see a figure and understand the question. For example, if you have a certain figure, like as we can see that we have a cylinder over here, right? We can clearly see that there is a cylinder over here. Now inside this cylinder there is an object which is a combination of a cone, students, along with a hemisphere that is lying inside it. So the question says a solid toy is in a shape of a hemisphere surmounted by a right circular cone. Right? The height of the cone is 2 centimeters. So this height of the cone is given to us. This one is given to us as 2 centimeter. The rest of the thing is, and the diameter of the base is 4. That means the radius of both cone and your hemisphere turns out to be 2 centimeter. Determine the volume of the toy if the right circular cylinder circumscribes the toy. That means completely takes it under it. Then find the difference between the volume of cylinder and the volume of toy. That means a difference, a subtraction of both of them. Alright. So first of all, what we have to calculate, the very first the task is to calculate the volume of the toy. Now this is the toy that is there, which is inside, which is a combination of what? A cone and a hemisphere. So volume of the toy, students, will be equivalent to volume of cone added upon volume of hemisphere. So these are the two volumes that we need to add up to find the volume of the total toy that is there in front of us. Alright, so let's see the volume of cone. What is the volume of cone? That is 1 by 3 pi r square h, plus volume of hemisphere is equivalent to 2 by 3 pi r cube. So these are the volume of different object. The one is for the cone, the second is for the hemisphere. Now what we can do student, is since pi, 3, h and h, everything is common over here, we can take it out, right? So what we can take it out from 1 by 3 and 2 by 3, we can take out 1 by 3 as common. Pi and pi, we can take out pi as common. From r square and r cube, we can take out r square as common. Now inside this we are left with h, plus from 2 by 3 we have taken 1 by 3 outside, that is 2, pi and r square, that means r. So we can make our equation more easy if we just take out common for what is there in both of them. So this will be equals to 1 by 3 into 22 by 7 into radius square, and the radius of both of them is 2 square, that will be 4. Right, height over here is given to us already, that is 2 centimeter, plus 2 into r, that is again 2 into 2, that will give us 4. So from here we can calculate the volume, since nothing is getting cancelled, so let's just solve it up. So we have 1 by 3 into 22 by 7, then we have into 4, and 2 plus 3, what we have over here is 6. So this will get cancelled out only, and we are left with that 22 into 8 divided by 7 will be what? Our particularly volume of the toy, which is combination of your cone and the hemisphere. So what we have over here is, you can straight away put, see if this pi is not getting cancelled, you can also put its value as 3.14. So this is nothing but 3.14 into 8. So 3.14 into 8, student, will give us 8 4s are 32. 3, 8 ones are 8, then we have 11, 8 threes are 24 and 25. So what we have as the volume, that is 25.12 centimeter square, which will the volume of the toy inside. The second thing that is being asked is to find out the difference of the volumes in the cylinder and the cone. The next thing that we have to find out is the volume of the cylinder. What is the formula for the volume of cylinder? Pi r square h. For that, we need the radius of the cylinder. See, as we can see that this figure is completely circumscribed inside the cylinder that is there. So if this is the radius of the particular cone and hemisphere, so this will only be the radius of the particular cylinder that we have. Now see, the top of the cone and the bottom of the hemisphere all together touches the top and the bottom of the cylinder. Listen to this very carefully. If this is the particular height of the cone, so from here A to B, the height of the cylinder will also be 2 centimeter. Now the radius is not only this but also this part of the hemisphere. See, this is 2, this is again 2. So the whole height of the cylinder becomes 2 plus 2, that is 4 centimeter. So over here what we are going to do, students, we are going to simply find out the volume of the cylinder. So volume of cylinder will be equals to pi r square h. Well, let's take pi as 3.14. Radius square will be equals to 2 square, and the height of the cylinder is already 4. So we have 3.14, 2 square is 4, 4 into 2 is 6. So we have to multiply 3.14 with 6, and then we will be getting what? We will be getting the area, the volume of things, right? So this is how we will just calculate, find the difference, and then do the particular thing. Right, so this is 2, the height will be 4, and then we have the radius as 2 square, that is 4, and we can simply calculate it further, right? Okay, over here height will be 4, sorry, 2 plus 2. So we have 4 into 4, 16. So 3.14 into 16 will be the volume of your cylinder. Now this will be subtracted by the previous volume that we have of the toy, and the difference of the things will be clear. All right, so let's see one more question that will be for your homework, and this is the question. Now, a mason constructs a wall of dimension 270 into 300 into 350 centimeter with bricks each size of 22.5, 11.25 and 8.75 centimeter. And it's assumed that 1/8 of the space is covered by the mortar, that means the mixture of cement and water that is used to make the wall along with the bricks, right? The number of bricks used to construct it. So this is what you have to find out. Do comment down the answer of this question down there, and I'll see you in the very next one shot, students. That will be of our next chapter, and we will be just completing whole NCERT of these one shots. So I hope that you're able to understand each and everything of this lecture, and if you have any doubts, feel free to write down and I'll be more than happy to help you out. So thank you so much. Have a great day ahead.